Yes. Okay. So what I was saying is, to find the singularity, we have to find the determinant of Jacobian, and from there, when you set the determinant to 0, then it will give us some condition where the robot is considered to be in a singular configuration. Okay, so we have to avoid that combination configuration as much as possible, as you know, as far as possible. So now sometimes finding the determinant is not easy task, because suppose you have 6 degree of freedom manipulator. So in that case, let's say we have a spherical wrist and the arm. Okay, because spherical wrist is almost you use that all the time, you know, for various purposes. I would say for various purposes we use spherical arm. Then we have to figure out the singularity for that arm, and also we need something to move the wrist, right? So that's what I meant by arm. So there is arm and there is wrist. So let's say we have 6 degree of freedom. We have a 3 degree associated with the arm and 3 degree associated with the wrist. Then what is the dimension of Jacobian in that case?
3 by 3.
Yeah, for the Jacobian has no. I'm talking about both arm and wrist. Arm has 3 degree of freedom, and wrist has 3 degree of freedom. In total, we have 6 degree of freedom.
Okay.
If we have 6 degree of freedom, then what is the dimension of the Jacobian?
2 by 3. No.
Yeah. Anybody else can help us? Guys, we need help. So in general, what is the dimension of Jacobian? 6 by n, right? Okay. So.
Oh, so it would just be a 6 by 1?
No, 6 by
No.
n. N means number of degree of numbers of joint, right? N means number of joint.
So 6 by 6.
Exactly. Right. Now what I'm doing here is I have the Jacobian, which is 2 by 2. Okay, what I'm doing here is this J11 is 3 by 3, and this J12 is 3 by 3. In total, we have 6 by 6. Similarly, we have J21 is 3 by 3. J22 is 3 by 3. In total, we have 6 by 6 again. Here, so what I meant is this guy, this is 3 by 3, this is 3 by 3, this is 3 by 3, this is 3 by 3. In that case, in total, we have 6 by 6. Does it make sense?
Yes.
Okay. So now in that case, this J11 is the Jacobian, and J12 is also Jacobian, J21 also Jacobian, J22 also Jacobian. And this J is the Jacobian of Jacobian. Okay. So now what is this? What is the top part? Top part is linear part of Jacobian, and the bottom is angular part of Jacobian, right? We know that. So here, but this one here on the, if you talk about the, let me do this here. What I meant is this is linear part of the Jacobian. This is angular part of the Jacobian. Okay. So similarly, we have a position and orientation portion also. This is the position part of the Jacobian, and this is the orientation part of the Jacobian, meaning this is for the arm and this is for the wrist. Okay, so arm, wrist, linear, angular. Okay, so what I'm trying to say here is, instead of calculating the determinant for all the 6x6 matrix, I can find the determinant of each determinant, because finding each determinant is easier than the whole, the entire determinant, right? Because entire determinant 6x6 is too much tedious. So instead of doing that, we can do this determinant individually. So that's what we call decoupling. Okay. Now we further we we have some other assumption. Then we are going to make it smaller. Okay. So we have now 4 components here. In my Jacobian we have J11, J22 minus J21 minus J12. I have 4 components. Now I'm going to reduce it by some assumption. Okay, let me do that. So what I'm saying here is, okay, this is just I'm elaborating the Jacobian here. So because my Jacobian is JP and JO, so JP is the position part, as I said earlier, and J0 is the orientation part. And JP, so JP is this, J11 and J21 is JP. And J12 and J22 is J0. So this is what I meant by this is J0, this is JP. I'm further condensing this again. Does it make sense?
I think so.
Okay. Now J0, which is orientation part of the Jacobian. What is J0 here? Orientation meaning, are you talking about arm or wrist?
J0.
Excuse me?
Oh, J0.
A J0.
It would be the wrist.
That's the wrist. That's the wrist, right?
Cool.
So now wrist meaning, so this is the wrist, right? Can you see this? Can you see this figure here? Wrist meaning we did wrist before, right? Do you guys remember that? We did wrist in the DH convention. We did that already. Let me show you. Just hopefully that will refresh your memory. We did the wrist in the DH convention. Okay. Do you see that? Now it should click your memory now. See the wrist? We did the wrist, right? In the DH convention. This is what I'm talking about. You see exactly the same wrist.
Okay. It looks familiar.
Right. That's what I am, Now, so how many joints do you have? You have 3 joints, obviously. And what is the nature of the joint? Are they prismatic or revolute?
Revolute.
It's revolute, right? So in the case of revolute joint, how do you find the Jacobian? So let me stop it here and let's move on. Okay. So what is the Jacobian for the revolute joint? So let me share the screen again. Okay. Can you see it now? My slide, PowerPoint. Okay. And this is frozen now. Okay, okay. Now, if you go back to the thing again, this guy again. So for the angular, because our sorry, for the revolute rather, for the revolute, what is the Jacobian? Because if we have this revolute part there, revolute joint, right, in the wrist, we have zi minus 1 times on minus oi minus 1 and zi minus 1 0. That's for the revolute joint, because we, as you said, we have 3 revolute joint for the wrist. These are the 3, and these are the, this is the formula for finding Jacobian for the wrist, which is revolute. So linear part for the revolute joint is this, and angular part for the revolute joint is this. Now, with that formula in mind, so what will be the Jacobian for the wrist? Means J0. J0 is the wrist, right? So what is Jacobian for the wrist? So this is the linear part. This is the linear part. This is the angular part. Angular part is easy because angular part is zi minus 1 0. Okay, zi minus 1. This is I equals to 4. This is I equal to 4. Okay, this guy is I equal to 4. The other one is I equals to 5. This is I equals 6. For I equals 4, for I equals 4, so what is zi minus 1? Z3. For I equals 5, what is zi minus 1? Z4. For I equals 6, zi minus 1 is Z5. So angular part is easy. Now, what is the formula for the linear part of Jacobian for the revolute joint? For the revolute joint, the angular linear part is zi minus 1, on minus oi minus 1. So in our case, on is, so this is 4, 5, 6, right? So O6. Then oi minus 1, O3 for the fourth one, right? And similarly, for the fifth one, O6 minus y minus 1, O4. Then for this other one, we have O6 minus y minus 1, which is O5. Does it make sense so far? I'm just talking about wrist, okay, not the arm. So then we will talk both together, arm and wrist together. For now, I'm just talking about wrist, J0 only. After I'm done with J0, then I'll talk about JP, which is arm. Guys, question here, please.
How are we finding our I again?
Oh, because remember, we are going to put this guy on top of the arm. This is the top part, right?
Right.
So arm has 3 joint and the wrist has 3 joint. So before the arm, before the wrist, we are going to have arm.
Right.
So I'm reserving 1 through 3 for the arm.
Okay.
Does it make sense?
Okay. Yep.
That's
All right.
why.
That now does make sense. Thank you.
Okay, that's why I started with 4.
Okay. Thank you.
All right. So now everything else makes sense.
I think so. Yeah.
Okay, good. Now I'm going to do the further assumption now, because I want to make my life easy, right? So that's why I'm going to do some assumption. So what I'm planning to do is, as you can see here in this wrist, right? So all the coordinate system, you know, intersect at common point O. Let me call this point O here. This point is common point for this. See, all of the coordinate system are at the same point O. Does it make sense? So it means I want to choose all the coordinate system right here, right at this point. Okay, I'm gonna put the coordinate system for this guy also here, and this guy also here, and this guy also here. I'm gonna put all the coordinate system right here at point O. Then what does that mean? If I do that, then your O3 equals O4 equals O5 equals O6, right? I can simply call O. All the origin coincide. All the coordinate system, you know, I want to put all the coordinate system at the same point, because that will, I think that will make my calculation easier. Okay, if I do that, then what does this become here? What is this? O6 minus O3, 0. O6 minus O4, 0. O6 minus O5, 0. Then I have top 0, 0, 0, 0, 0, 0, Z3, Z4, Z5. That's what I have here. 0, 0, 0, Z3, Z4, Z5.
And that's all because the wrist is all 1 point.
No, I have decided to choose the coordinate frame for this wrist in such a way that my origin is exactly same point. I choose the single origin for all of them. So normally we choose the origin here, 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 and here, right? 4 different places. This is for the end effector. This is for the joint 3. In our case, joint 6. This is joint 5. This is joint 4. 4, 5, 6, and this is the end effector. We have 4 different locations of the coordinate frames. But instead of doing that, what I'm doing here is I'm choosing all the coordinate frame here. I'm gonna put everything here. If I do that, my O3, O4, O5, O6, they're all here, all here. If that happens, then what happens here? This O6 minus O3 is, they're same, right? That's why 0. This is also 0. This is also 0. In that sense, my top is all 0. Then we are left with just bottom part only. So I'm assuming that this assumption will simplify our problem. That's why I'm doing this.
Okay.
Okay. Now my J0 is done. Now what is our next part? J0 is done. Let's find the JP now. Let's find JP, what it looks like. JP is the arm, right? It's the arm. All right, so arm definitely has 3 joint also. And we don't know about the arm. The arm could be prismatic, you know, arm could have prismatic joint, also could have revolute joint, right? We don't know about that yet, because we can take different kinds of arm. We have just one kind of wrist and different kinds of arm. Does it make sense?
Okay.
So now for the arm, so we have to find JP, right? For the JP. So JP meaning we have J11 and J21. We have to figure out this thing, right? That's my JP. So what is the linear part of JP? J11. What is the angular part of JP? J21. I need to figure out J11 and J21. So how do you find the linear part of the Jacobian? This is the angular part, this is the linear part. So again, go back to the table there, right? So remember we have the table back somewhere here. So if the linear part is, if it is revolute, this is the linear part. If it is prismatic, this is the linear part. Okay. Similarly, angular part, which is J21, okay, J21. This is J11, this is J21. Top is linear part, bottom is angular part. For the J21, if the joint is revolute, we have Zi minus 1. For J21, if the joint is prismatic, then this is the Jacobian. That's what I said here. Exactly here. Okay. For the ith joint that is revolute, see, my J11I. Because what is the J11? How many columns sign? How many rows do I have for the J11? 3 rows, 3 column. This is 3 by 3. 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 So in total, we have 6 by 6. You understand why this is 0, right? Because of that. Because of this guy. I call this everything the 0. Big 0 now. Big 0 includes 3 small zeros. Okay. That's my big 0 here. This is my big 0. And J22, we already done that. J22 is Z3, Z4, Z5. Now I'm talking about J11. J11, linear part of the Jacobian for the arm. So, yeah, go ahead.
No, I just sat down. You're good.
Okay, so now since J11 has 3 columns, right? Obviously, this has 3 row, right? 3 row, that's fixed, right? Row is always fixed. For J11 is always 3. J21, the row is 3, right? Because we know 6 by n. Now, in this case, in our case, your n happens to be 6. That's why this has, this is 3, this is 3, makes 6. Here, this is 3, this is 3, that's why 6. So our n also 6. Now, here I could be 1, 2, 3, because we have 3 of them, right? I could be 1, 2, 3. J11 first one, J11 second one, J11 third one. Meaning J111, J112, J113, column wise. Does it make sense?
Yes.
Okay. So then we'll use different formula depending on whether the joint is revolute or prismatic. So revolute, you use this formula, as you know, and prismatic, you use this formula. So this formula, one of those formula goes in here, depending on, revolute or prismatic. Okay, this is how we fill in this column here. Now, as you see here, this is what I said. Now, what is your determinant of this J here? Let me go back here and calculate the determinant, because our final goal is to determine the determinant and set it to 0, right? That's our final goal. So now, how do you find the determinant of this guy? Determinant of J, determinant of this matrix here, this matrix itself. Then what is the determinant of this matrix? Help me here. J11, J21, J22. This is how you find the determinant, right? And you cross, you do the cross, multiply like this, right? So J21 times 0. That's why minus J21 times 0 is 0. That's why we don't have it here. Minus 0. That's the determinant of J. Guys, make sense? Now, instead of finding 4 determinant, now I just have to find the 2 determinant, J11 and J22. So what can we conclude from here? is if you want to find the determinant of J, then find the linear part of the determinant, linear part of the Jacobian, and linear part of Jacobian for the position, and angular part of Jacobian for the orientation. I want you to understand this clearly.
Is that for any Jacobian problem?
Yes,
Okay.
but remember, you have to make sure this guy is 0, right? That's the assumption.
Oh, right.
Okay, so this is any Jacobian. What I meant by any Jacobian meaning, you have 6x6 robot, and your wrist is wrist. You have only one kind of wrist, but arm could be any kind of arm. In that sense, we can say any kind of Jacobian, but it has to be, arm has to have 3 joint, and wrist obviously has 3 joint. If you are dealing with that kind of problem, then this is always true. In that sense, we can say any kind of Jacobian. In that sense only. Now, to find the Jacobian, to find the determinant of all the entire arm plus wrist, you just find the determinant J11, determinant J22, because instead of finding, J21, and you don't have to find J21 here, because J21 multiplied with 0 becomes 0. So you simplify the problem by 50%, because this term is completely gone. This is gone means you have 50% less burden. Okay, then what is this J11 and J22 then? So we don't have to worry about anything else. You don't have to worry about J21 and J12, because you don't have to worry about this guy here. You don't have to worry about this guy, just the J11 and J22. What is J11? J11 is the linear part of the JP, right? And J22 is angular part of JO. Remember, we had JO and JP here. Position and orientation. Okay, P for position, or position meaning arm, orientation meaning wrist. Okay, so J11 is the linear part of the Jacobian for the arm. J22 is the angular part of the Jacobian for wrist. So you just have to care those 2 things and multiply them together and find the full determinant. Then you can set it to 0. You find the determinant, then you set it to 0. And from that condition, you get the condition for singularity. Is it clear?
Yeah.
Now, let's do the wrist here. Let's find this wrist singularity then. So what is the wrist singularity? Meaning, so you just have to do the angular part of the Jacobian for the wrist, right? If you want to find the wrist singularity, you just set it to 0. If you want to find the arm singularity, you just set it to 0. If you want to find the singularity for the entire system, then you set it to 0. Now, what I'm asking is find the wrist singularity. If you want to find the wrist singularity, it means this J22 should be 0. J22 should be 0. What is J22? Angular velocity Jacobian for the wrist. So angular velocity for the wrist. So what is the angular velocity Jacobian for the wrist? This is the angular velocity Jacobian, right? J3, J4, and J5. Okay, so you have to do that here. J3. So this is what you do. Find the determinant of this guy here. Determinant of J22 equals 0. That's what you do. Determinant of J22 equals 0. So how do you find the determinant of J22? You have to find J3, G3, Z4, and Z5. So G3 is a column matrix like this. It has 3 rows. This is also column matrix. This is also column matrix. Each column has 3 rows, right? That is, so G3, Z4, Z5, they consist of 3 by 3 matrix. Then find the determinant of that 3 by 3 matrix and set it to 0. Then from there you can find the condition for singularity. But the thing is, how do you find Z3, Z4, Z5 for this? How do you find Z3, Z4, and Z5 for this configuration? Once you have Z3, Z4, Z5, then you can, put them in a row, a column-wise column, G4, G3 first column, Z4 second column, Z5 third column. Then you make the Jacobian and find the determinant and set it to 0. Then after doing that, you will get the condition for the singularity. The thing is, how do you find Z3, Z4, and Z5 now? Does this make sense so far so good?
I think so.
Okay, so how do you find Z3, G4, G5? So for that, I'm not going to do too much here. Just I'm going to show you how you do it. Okay, so just I'll give you some idea. Okay, let me show you how you do it. Now let me go to chapter 3. Oops, you can see the, okay, let me stop it again and I'll show you how we did it. So we had different methods of finding Jacobian. Remember we did that last time. We at least had at least 3 methods of finding Jacobian. Let me take you there. What are those methods for finding Jacobian? Where is it? Did I not talk about it? Yeah, there, right? Remember, if you want to find the Jacobian, so what do? You can find that Jacobian from the Denavid-Hartenberg convention, right? So from the Denavid-Hartenberg, you can find A1, A2, and A3 in our case. For the wrist, we have A1, A2, and A3, right? And how do we find the Z1, Z2, G3? Or in our case, G3, G4, because in our case, this will be A4. We start with A4, right? A4, A5, A6. Then in A4, that's my Z4. No, we start with the A3. Yeah, first one is first Z, okay? That's what I meant. Then you have A1, A2, then you get Z2. Okay? Then A1, A2, A3, you get Z3. Make sense? Guys, question here, please. How do you find Z1, Z2, G3? Or in our case, G3, G4, G5 from the A matrix that we did in the Denavid-Hartenberg convention.
Okay, so it's kind of like setting up setting up what we had been doing a few weeks ago, and then we just pick the Z out of it.
Exactly.
Okay, cool.
Yeah. So you see how you said, okay, now, and we already know that A1, A2, A3 for the wrist. Remember, we already know that. See, these are our A4, A5, and A6. So from here you get Z3, Z4, not Z4, you have to multiply these two guys. Okay, from here you get Z3, from here you get, no, not from here, you have to multiply this guy with that guy, then you get Z4, then multiply all together, you get, yeah, this is your Z, you know, final Z.
Okay. Oh, just a quick question. Would you have to multiply A 1, 2, and 3 with 4 to get Z4? Or because we're just talking about the wrist with 4, 5, and 6, we're not caring about A 1, 2, 3.
Yeah, we don't care about a 1, 2, and 3.
Okay. Okay, cool.
Okay. Yeah, so we don't care about that. This is for the arm. Okay, when it comes to the arm, then we'll talk about that.
Okay.
Okay, for the wrist. So, oh, this is the on the previous. Okay, now let me go back to my. All right, so we have it here. Okay, now once you have, once you have A1, A3, A4, and A5 from, then you can figure out Z3, Z4, and Z5. Then set that to 0, and from there you can find this condition. So you get, you know what you get in that case, you get a sine theta 5, negative sine theta 5 equals 0. You get that. When you do the determinant and set it to 0, then you get negative sine theta 5 equals 0. It means theta 5 equals 0, pi, 2 pi, that kind of stuff. So that indicates the singular configuration for wrist. Okay, or in other words, we call it wrist singularity. That's how you find the wrist singularity. And similarly, how do you find the arm, right? Arm singularity. Let's do one arm. Okay, so because there are wrist, there is only one kind of wrist, but the arm we could have any kinds of arm. Now this is one of the examples. The arm called elbow manipulator. So in this case, we have to, for the arm we have to do J11, right? So what is J11? Linear part of the Jacobian. Linear part of the Jacobian for the arm. So in this case, what does the arm consist here? This arm also consists of 3 revolute joint, similar to wrist, right? In the wrist, we had 3 revolute joint also, but in our particular arm here, which is called elbow manipulator, in the case of arm also, we have 3 joint in this particular arm. So now, if you want to make the entire manipulator, then you have to put the wrist here, wrist. So 0, 1, 2, then 3, 4, 5, 6, you know, that way. That becomes our complete robot. Okay, so if you want to find the Jacobian for this arm, then what do you have to just, for the arm, you have determinant of J11 equals 0, right? That's how you find the Jacobian for the singularity for the arm. Just worry about J11. What is J11? Linear part of the Jacobian for the arm. You don't have to worry about the angular part. That's the good news. So how do you find the linear part of the Jacobian? Since we have all revolute joint. Remember the table there? Zi minus 1 On. In this case, this is, you know, I call this C. My N is C. Okay, so that's why I say OC minus O0, OC minus O1, OC minus O2. Because remember, we have I minus 1, 1 minus 1, 2 minus 1, 3 minus 1. Does it make sense? Guys, question here?
So from 0.00, we're starting at I equals 1.
Yeah, this is 1. This is I equals 1, I equals 2, I equals 3.
Okay.
Remember we had I equals 4 for the wrist?
Right. Okay. Yep, that makes sense.
Yes, for the wrist we have I equals 4. So I equals 1, I equals 2, I equals 3 here. So I
Cool.
minus 1, yeah, I minus 1, 1 minus 1, Z0. I equals 2, 2 minus 1, Z1. I equals 3, 3 minus 1, Z3, Z2. So similarly, you can find O, OC, O0, O1, O2. Again, you can use the same, A matrix, right? Remember the way we did for the wrist? Find the A matrix, A1, A2, A1, A2, A3. Once you do that, you'll find Z1, Z0, Z1, Z2, and all the O's. And if you do, then you can find, finally you can find this one, okay? I just gave it to you. You don't have to. If you do that, you will get that. This is what I meant, okay? This is how you get that. Then if you
Okay.
find it, go ahead.
Oh, no, I was just saying, okay.
All right, so then determinant, if you want to find the determinant of this guy, there is a lengthy calculation here, okay? After you do that, you get determinant equals this here. Okay, after you simplify, you get this. Then finally, you have to set this to 0, right? To find the singularity. And when you do that, you get this. So meaning either S3 is 0 or this guy is 0. When S3 is 0, then what do you get? Theta 3 is 0 pi, 2 pi, stuff like that. And when this guy is 0, then you get this. When this guy is 0, actually this corresponds to the wrist center intersecting the Z0 axis. That's why this is not possible if there is shoulder offset. Okay, so just here. So this determines our singularity. All right, so we don't have time. Otherwise, I would go through this. I don't have too much now. I have just 1, 2, 3 slides now. Actually, 4 slides. So we can easily finish on Friday. So unless you guys have any questions, I'm done for the day.
Would you mind going back to where we set J12 equal to 0? That I'm still a little iffy on that.
J12 equals 0.
Yeah. Back another slide.
J22 equals 0. Or J11.
J12.
Or J12. Did we? J12 is, this is J12 0. Can you see the slide here? Is this what you meant? Emery, are you there? Hello?
Oh, sorry. I've,
This is what you meant
no, 2 slides forward.
here?
Yes.
Okay. So what is the question here?
How are we getting it equal to 0 again?
Oh, okay.
A bit iffy.
So no, because remember in this spherical wrist, so all the axes intersect right here.
Okay.
Okay, when all the axes intersect right there, meaning our origin, all the origin is here. For this axis, we say the origin here. All the axis is right here. If you do that, then you get all of them equals to O. Everything is O. Okay, if everything is O, then this is O. This is O. O minus O. you know, whatever be, O could be 5, you know, 5, 3, 2. O could, then this is 5, 3, 2 also. O minus O, 0. Then this is also O, this is also O. You know, 5, 3, 2, 5, 3, 2. That's for example, right? Then this is also O, this is also O. 5, 3, 2, 5, 3, 2.
That makes sense.
Then you get 0, 0, 0 everywhere. So that's why your entire top part is 0.
Okay, thank you very much.
All right. So any other question, guys?
I don't think so.
Okay. Thank you so much, guys. So stay safe and see you Friday.
Same to you. Take care.
Bye-bye.
See you later, everybody.
Have a good one, Professor.
All right. Thank you. You too.